Okay, in this video we're going to look at how to solve absolute value equations algebraically. So here's some rules for absolute value that we're going to be using. This is the absolute value of x equals a, so equals some value where a is a constant. If this is true, then x is going to equal a and x is going to equal the opposite of a, so a positive and a negative. For example, if the absolute value of x is equal to, let's say, 4, then it makes sense that x can be positive 4 because the absolute value, if I plug 4 in here, the absolute value of positive 4 is 4, or x can be negative 4 because the absolute value of negative 4 is 4. So that's our general statement for equals. Now, here you see we have a less than symbol. So if the absolute value of x is less than some constant a, what we're going to do is we're going to set it up like this. Okay, so we're going to take the opposite of a, the negative version, and put it on the left. And we're going to say that that value is less than x, which is less than a. So as an example, if the absolute value of x is less than 3, then what we know is that we're going to take this 3 and we're going to say negative 3 must be less than x, which must be less than 3. So I took this value, I made it negative and put it here. X is in the middle, and then I have the positive version of that here. And that makes sense because if the absolute value of x is less than 3, you can pick any number between these, like negative 2, and the absolute value of negative 2 is 2, which is less than 3. Okay, and you'll see that this is always positive here. This 3 has to be positive because the absolute value of x is going to be a positive number. So I can't say that the absolute value of x is less than negative 3. That would never be true. Okay, so then this one is our greater than symbol. So if the absolute value of x is greater than some constant a, what you see is x is greater than a. So that looks almost exactly the same as we have here, except we don't have the absolute value symbol. Or x is less than the negative version of that. Now, I really think what we should have done is taken this one and taken this one, and we should have swapped the order because I like to have this one first, and you'll see why. It makes more sense when we read the answer that way. But if the absolute value of x is greater than 5, then, now I'm going to start with this one over here, and I'm going to say we know that we're going to take x and say it must be less than the negative version, so negative 5. Or now I'm going to do this one, x is greater than positive 5. And I like it this way because this is proper, because what this is saying is x is less than negative 5, so on a number line you're going this way. Or x is greater than 5, so on a number line you're going this way, and then what you have is a gap in the middle. So none of the numbers from negative 5 to 5 between those two work. Okay, it just makes more sense to write it this way, so I'd like for you to get in the habit of doing that. Now this is a special case where notice you have an absolute value here and you have an absolute value here. When that's true, and this is going to work for equals, this is going to work for less than, this is going to work for greater than, so you're going to see me do it for all of them. If you have an absolute value on both sides, then we can just square both sides and solve. Because ultimately, if this is the absolute value of something inside, it's always going to be positive. And this is the absolute value of a constant, which will always be positive. And if both of these sides are going to always be positive, then squaring them, they'll stay positive, and we're squaring the values, and they would still be equal to each other. So if the absolute value of x is, let's say, equal to the absolute value of negative 3. Okay, if this is true, what I can do is I can actually square both sides. Okay, so I'm going to drop the absolute value and square, and I'm going to get x squared is equal to negative 3 squared is 9. Well, when we solve that, we square root both sides, and we get x is equal to plus or minus 3. And so it makes sense in this statement if I plug in a positive 3, the absolute value of positive 3 is 3, and the absolute value of negative 3 is 3. So no matter what I plug in, that's going to be a true statement. Okay, it does work for less than and it does work for greater than, and you're going to see me do that. Now those were some basic examples where all I had inside my absolute value was an x. So we're going to look at some examples where we have more going on. Okay, so I'm just going to go through a few of those. Absolute value of 2x minus 3 is equal to 4. Remember, this is an equal sign, so all we're going to do is take everything that's inside our absolute value and we're going to say, well, this has to be equal to the positive 4, or everything that's inside my absolute value has to be equal to a negative 4. Because regardless as to what the result of this is, positive or negative, when I take the absolute value, it will be positive. So it can be either. And then we solve both of these as normal. So we're going to add 3 to both sides. We're going to get 2x equals 7. Divide by 2, we get x equals 7 over 2. Here, I'm going to add 3 to both sides. I'm going to say 2x equals negative 1, divide, and I'm going to get x equals negative 1/2. Now, you should always, it's a good habit to always check your answers here by plugging in, okay? But these are our 2 answers for this. Both of those will satisfy, okay? Let's look at this one. This one is a less than or equal to, but we do have this 2 out front. So you kind of have 2 options here. You could divide this side by 2 so that on this side you had 7 over 2, and that would be fine and you could work that way. But since this is a positive, and only because it's positive, and with these absolute value here, this will always be positive, I can actually distribute it in. So I can actually say 2x plus 10, the absolute value of that, is less than or equal to 7. I can do that if it's positive. Now I can use my rule for less than, so if you need to go back and look at your rules, that's fine. And I'm going to take this 7 and I'm going to make it negative, and I'm going to say negative 7 is less than or equal to everything that's inside my absolute value, which is now 2x plus 10, is less than or equal to positive 7. Now, you can actually split this up. You can actually take this and you could take this part and write that as one equation, and you can take this part and write that as one equation, and that will work. So you'd have 2 equations and you can solve. But we can actually just solve it and be careful that when we subtract 10 from the inside, because remember we're trying to isolate x, I can subtract 10 from both sides. So in this case, I am going to have negative 7 minus 10 is negative 17, is less than or equal to, I have a 2x in the middle, which is less than or equal to 7 minus 10, which is negative 3. And now, of course, I still want to get x by itself, so I'm going to divide by 2 on all sides. This is going to give me that x is going to be somewhere between, or any value between. X can be any value between and including, because we have these are equal to, negative 17 over 2 and negative 3 over 2. So any of those values work. And again, you should always pick some test values and check and make sure you're careful with your math. But that is the answer for that problem. Okay? Okay, on this one again, we need to isolate the absolute value. We need to get it by itself. So we're going to move this 5 in front by subtraction. That's going to give us negative, and we have the absolute value of x minus 2 is less than negative 4. Now, this is a negative in front. You have to deal with that. It's a negative 1, so you can put a 1 there if you want to. I'm going to divide both sides by negative 1, but you have to be very careful because when we divide by a negative 1, this sign gets flipped. We flip our inequality. So instead of less than, it's going to be greater than. We have the absolute value of x minus 2, and then negative 4 divided by negative 1 is positive 4. So now I have an absolute value that's greater than, so I would need to go look at my greater than rules. My greater than rule, remember, is I'm going to take the x minus 2, I'm going to make it less than the negative 4, or I'm going to have x minus 2 is greater than the positive 4. And then, of course, I'm going to solve for x. I'm going to add 2 to both sides, and this is going to give me x is less than negative 2. Or, when I add 2 to both sides here, I get x is greater than 6. So anything that's less than negative 2 or greater than 6 would satisfy this and make this a true statement. And, of course, you should always check your work. Okay, on this example, we have an absolute value on both sides. So remember I said if you have an absolute value on both sides, you can just square both sides. So if we do that, though, we have to be careful because we have this 3 in front. So now I could have moved the 3 inside since it's positive, and since it's positive, I could just square everything. So that's kind of a choice. That's a preference for you. But if I square it, I'm squaring the 3, and I'm squaring the x plus 1. And then on this side, I'm squaring the 2x minus 5. So you just really have to be careful not to forget about that 3. You're squaring the whole side, so the 3 has to get squared. This is going to be 9. When I square this x plus 1, I'm going to get x squared plus 2x plus 1. And then on this side, when I square 2x minus 5, I'm going to get 4x squared minus 20x plus 25. Now I need to distribute my 9, so you guys know how to do this part. This is just solving. I'm going to have 18x plus 9 equals 4x squared minus 20x plus 25. Okay, and then of course I need to move everything to one side, so you guys can do that. But when I do, I'm going to choose to move this side over here to the left, since this is a positive 9x squared. And when I do that, I'm going to have 5x squared minus 38x minus 16 equals 0. And that's a quadratic, so you could factor it if it's factorable, or you could solve using quadratic formula. I'm not going to show those steps because you know how to do that. And x is equal to 2/5 here, or x is going to be equal to -8. So these are my two answers for this, and of course again, check your work. Alright, let's go through one more example before you try these problems. Notice that this has an absolute value on both sides, just like the last one did, but it's less than. So remember I said you can actually use this rule if it's equal to, less than, or greater than. So I'm just going to square both sides. So when I do this, I'm going to get 4x squared minus 4x plus 1 is less than x squared minus 4x plus 4. And then just like the last problem, it's quadratic. We need to get everything on one side, so I'm going to move this side to the left. That's going to give me 3x squared. When I move this 4x, those are the same sign, so when I move this over by addition, that's going to go away. And then I'm going to have minus 3 is less than 0. Again, this is quadratic, so you could use quadratic formula, but I'm going to take out a 3, which gives me x squared minus 1, and that's factorable. So I get x minus 1, x plus 1 is less than 0. And then you should be seeing this, and hopefully you remember that we have to be careful because this is a quadratic inequality. When you have an inequality, remember, and you have an less than sign, so you have an inequality, and it was quadratic. See, there's two x's. I can't just say my answer is 1 and -1. Remember that I have to consider my graph. I have a value at -1, I have a value at 1. Because this is a positive coefficient on x squared, my graph opens up, but I am asked for where is it less than 0. So I'm looking for this part, which means I have to state my answer as x is between, and then we're going to put the smallest one here and the largest one here. So this says x is between -1 and 1. So you have to watch out for this, okay, if you have an inequality and it's quadratic in absolute value or in anything we solve, okay? Okay, I want you to try this problem first, and then pause the video while you try it, and then check and see if you got the same answer I did. Okay, so again, it's a less than or equal to, so less than rule is what we're looking for. We're going to take that 4 and we're going to make it -4 is less than or equal to everything inside our absolute value, which is less than or equal to a +4. And then we're just going to solve by moving my 3. Remember to do it in all places, or you need to separate this into two equations if you'd prefer to do it that way. So we have an x left in the middle. -4 and -3 makes -7, and then 4 and -3 makes +1. So x is any value between -7 and 1, including -7 and 1 in this case because of this or equal to. Okay, take a minute and try this next problem. Pause your video and then check to see if you get the same answer I did. Okay, in this example, it's greater than. So remember, we're going to take everything inside the absolute value and we're going to say is less than the negative version. And then we're going to take everything inside and leave it as greater than 9. We're going to solve both. So adding the 1 here is going to give me 2x is less than -8. Dividing by 2 gives me x is less than -4. Over here, when I add 1, I get 10 on the right. Divide by 2, I get x is greater than 5. So x is less than -4 or x is greater than 5. Okay, I want you to do the same thing. Take a minute and try this problem, pause your video, and then check your answer with me. Okay, this is an equal sign. So we're going to take everything inside our absolute value. We're going to set it equal to +14. and we're going to take everything inside and set it equal to negative 14. And this is equal, so it doesn't really matter which one you do first. You can do the positive or the negative 14 here. We are going to solve this, so when I add my 4, I get 3x equals 18. Divide by 3, x is going to be equal to 6. Adding my 4 to the other side here is going to give me negative 10. Divide by 3, and I get x is negative 10 thirds. So x can only be two values here, either 6 or negative 10 thirds. And of course, you should check your answer in this. All right, again, we're going to do the same thing. Try this one and then check your answer with me. Okay, on this one, the absolute value does have to be isolated, and some of you may have noticed this looks very similar to an example I did, but it is slightly different, so you couldn't just copy that example. But I do need to move the 5, which we did in the other example. X minus 2, I have the absolute value with a negative in front, is greater than negative 4. And when I divide by this negative 1, remember you have to change this inequality sign. You have to flip it. So now I have the absolute value of x minus 2 is less than a positive 4. Now it's a less than problem, so remember the rules for that. Negative 4 is less than x minus 2, which is less than positive 4. Move your 2. Make sure to do it to both sides. And I have x is between, this side's going to give me a negative 2, and this side's going to give me a 6. So x is between negative 2 and 6. All right, last problem. I want you guys to try this one, and then check your answer with me. Okay, this one has an absolute value on both sides, so I am going to square both sides. Again, remember this 2, it has to be positive, but this 2 can be distributed in here if you want to, so you have it inside your absolute value. Or you can square both sides, but you're going to have to remember that the 2 gets squared also. So when the 2 gets squared, I would have 4, and then I would be squaring my x minus 1 squared is greater than x plus 2 squared. So now I have a 4. When I square this, I'm going to get x squared minus 2x plus 1 is greater than x squared plus 4x plus 4. Distribute my 4 all the way through. It's going to give me 4x squared minus 8x plus 4 is greater than, and I didn't really need those parentheses on that side, so I have x squared plus 4x plus 4. And now I'm going to move everything on this side to this side here, and I'm going to have 3x squared minus 12x. And actually, when I move that 4 goes away. It adds to 0, so I'm going to have is greater than 0. And again, you can solve this in a couple different ways, but I'm going to choose to take out a 3x as my greatest common factor. That gives me x minus 4 is greater than 0. But I hope you remembered that this is a quadratic inequality. So while normally we would get a 0 for this x and a 4 for this, we do have to consider the fact, here's my 0, here's my 4, that this is positive, so my graph opens up, but you have to check to see what part of your graph were you considering. You wanted greater than 0, so you wanted above the x-axis. So that is when x is less than 0, because this is to the right of 0. You can see this part of my graph. I'm sorry, not to the right, to the left. You can see that this part of my graph is to the left of 0. And that this part of my graph, if it keeps going, when it keeps going, is going to be to the right of 4. So, or x is greater than 4. So you have to give it to me in this form. You can't just give me 0 and 4. Okay? All right, I will see you in class.